In this video, I'm going to introduce modular arithmetic and connect it to some concepts we have already learned. So first I'm going to define a relation R on the integers. So I'm defining R, which is a subset of Z cross Z, where if you take any two integers A and B, A is related to B if and only if A and B have the same remainder when divided by 5. Okay, so this is our relation. Two integers are related if they have the same remainder when divided by 5. So this means that 32 is related to 17. Just as an example, 32 is related to 17 because they have the same remainder when divided by 5. Let's see this in action. 32, when divided by 5, goes in 6 times. 5 times 6 is 30. Subtract, you get 2. Your remainder is 2. 17, when divided by 5, 5 goes in 3 times. We get 15. Our remainder again is 2. Now think about what this means, right? This over here means that 32 is equal to 5 times 6 plus 2. And this over here says that 17 is equal to 5 times 3 plus 2. Okay, now I'm going to do some funny arithmetic here. Just good old regular arithmetic like you know already, but you're going to be wondering, why didn't I actually subtract that? And the reason I'm not doing it is because I'm going to do it in general in a moment. So I want you to see it with some numbers first. Okay, 32 minus 17, that's equal to, okay, so 32, this is another way of writing 32, right? So I'm just going to write that other way right here. 5 times 6 plus 2 minus this other way to write 17. Now let's see, let's distribute that negative. So we get 5 times 6 plus 2 minus 5 times 3 minus 2. Notice the 2's will cancel. And then we get 5 times 6 minus 5 times 3. I can factor out the 5. I get 6 minus 3. So that says that, so 6 minus 3 is 3, so that says 5 times 6 minus 3 is 5 times 3. Okay, remember this. A and B are related if they have the same remainder when divided by 5. Okay, so what we've found with this calculation here is that 32 minus 17 is equal to 5 times 3. Dividing both sides by 5, we get that 32 minus 17 over 5 is equal to 3. Now 3 is an integer, right? So what this tells us is that 5 divides 32 minus 17. And also, to say that 5 divides 32 minus 17 is the same as to say that 32 minus 17 over 5 is equal to some integer. So I'm going to put this little double arrow there, meaning that if you have this, then this is true. If you have this, then you know this. They're equivalent ideas. All right, so now the general case. Now let's say that A is related to B. And A and B are integers, right? So that means that A and B have the same remainder when divided by 5. Okay, so let's say that a and b are any two integers and they're related. So that means because we've defined our relation this way, that a and b have the same remainder when divided by 5. Okay, so that means if you do this division thing, right, or just using the division algorithm, that means that a is equal to 5 times some quotient, let's say quotient 1 plus r, and it also means that b is equal to 5 times some quotient, say quotient 2 plus r. And why do we know these are the same? Right? Because we said they're related. And we defined our relation to be that two things are related, two integers are related when they have the same remainder when divided by 5. Remember, this is the divisor. So they're both divided by 5. They have different quotients, but they have the same remainder. Okay, so now a minus b is equal to 5q1 plus r minus 5q2 plus r, which is 5q1 plus r minus 5q2 minus r. So again, the r's cancel. And we're left with 5q1 minus 5q2. We can factor out that 5. We have 5q1 minus q2. So now see what we've established here is that a minus b through this string of equalities, let me give myself a little more room here. Through this string of equalities, a minus b is equal to 5q1 minus q2. Now if we divide both sides by 5, then that means that a minus b over 5 is equal to q1 minus q2. Now remember that q1 and q2 are integers. The division algorithm tells us that these are integers. And when we subtract two integers, we get an integer. So this right here, this is some integer. So that tells us that 5 divides a minus b. And so from all of this, what we can see is that 5 divides a minus b is equivalent to saying that a and b have the same remainder when divided by 5. And so the idea is that we can characterize integers by their remainders when you divide them by the same number. The same number, the same integer that's bigger than 1. All right, so often instead of writing 5 divides a minus b, we'll write something like this. This is equivalent to saying a is congruent to b mod 5. So what I'm trying to show you here is that here we have 3 different ways of saying the same thing. If you say a is congruent to b mod 5, that's the same as saying that 5 divides a minus b. And saying that 5 divides a minus b is the same as saying a and b have the same remainder when divided by 5. Now there's nothing special about 5 except that it's an integer bigger than 1. And so to generalize, we might use, instead of a 5, use an m. So in full generality, we would say a is congruent to b mod m is the same as m divides a minus b, is the same as a and b have the same remainder when divided by m. And for me, this last characterization here, that they have the same remainder when divided by m, this really helps out a lot. I'm doing this modular arithmetic stuff.